Hi, I wanted to give you some background information for the Science Month. I just want to preface this with saying this is oversimplification. You could certainly learn a lot more about this if you want. But I think at a middle school level, this is enough to get you started with what we would like you to do this month. So the sun emits energy across a lot of different wavelengths of electromagnetic waves. So we call this the electromagnetic spectrum. And sort of at the low energy end, there's AM radio. Radio, you might know those from your parents' car. Then sort of above that, there's microwaves. You know, you probably heat things up in a microwave oven in your kitchen. If you have a cell phone, your parents have cell phones, they work in the microwave part of the spectrum. Above that, we have infrared. Then there's visible. The visible part of the spectrum, we break that down into red, orange, yellow, green, blue, indigo, violet, the colors in the rainbow. Above that is ultraviolet. X-rays, and there's gamma rays. In terms of energy, this is the low energy end of the spectrum. This is the high energy end. The temperature that's emitting the energy has something to do with where it falls on the spectrum. Humans, at our temperature, we tend to emit in the infrared. Whenever you're warmer than your surroundings, you're giving off energy. Infrared part of the spectrum. Some night vision goggles are designed to see in the infrared. This is what humans detect. And then somewhere up here in this ultraviolet region, this is where there's enough energy that this could damage cells. And now if we look at what our sun puts out, so I'm going to try to make a graph here. And what I want to put on this axis, I do have a lot of trouble making my smartboard work. So this is energy per second over, I'm sorry, do it this way. This is energy per time all over area. So if you, hopefully soon we'll have some warm sunny days. If you go outside and stand in the sun, you feel it warming your face. The skin, the surface area of your face is absorbing so much energy in the sunlight per second, and we perceive that as warmth. So our star emits all across the spectrum. It happens to peak up here. And it turns out the very peak of this is this yellow-green color. Tennis balls are that color. People that work along the highway picking up trash or working, they wear vests that are this color. And it turns out we've evolved to see that color the best because that's the brightest part of sunlight. If you look at what makes it to the Earth, then let's see. So the visible light makes it to the Earth. A little bit of the ultraviolet light does. You may have heard of the ozone layer that absorbs a lot of things. On this side, there are, I don't know exactly where, there are like some dips. There are gases in our atmosphere that absorb some of the parts of the spectrum. But basically, we get energy from the sun. What gets through our atmosphere is visible light, the red, orange, yellow, green, blue, indigo, violet, and the peak of that is this yellow-green color. So that's the energy that we're receiving. Now, a lot of what we see is by reflection. So if you have light coming into your eyes, and let's say it's red, orange, yellow, green, blue, indigo, violet. Let's see. So the human eye has specialized cells that can detect red, green, blue light. There's some debate about whether we see yellow or not, but I think everyone agrees we see red, green, blue. You may have seen like a monitor called RGB monitor. It's because it's emitting red, green, and blue lights. And so our eye makes all the colors from those three. And if we see those three in equal amounts, we see white. If we see different percentages of different parts of this visible spectrum, that's how we see different colors. Okay. And then a lot of what we see is because of light reflected off of it. So for example, my students usually make fun of me for my poor artwork. But suppose you see a fire extinguisher. And I'm not really sure what fire extinguishers look like, even though there's one in the room somewhere. The ones in my school are red. So what happens is red, orange, yellow, green, blue, indigo, violet light, which you would perceive as white, shines on the red fire extinguisher, and what happens is red is reflected. So if someone is standing over here, they see the fire extinguisher and they say, oh, it's red. So what's happening to the other colors? So the orange, yellow, green, blue, indigo, violet is absorbed by the object. And remember, these different parts of the spectrum represent energy. So some of the energy is reflected in terms of the red light, and the other colors are absorbed. So the pigments that make up the paint that's on the fire extinguisher are absorbing energy. So maybe let's try this. You probably experience this if you take two students, let's say they go outside in the sun. One of them is wearing a black t-shirt. Not sure how to draw white with my smartboard. Maybe white is the color. That's not going to show up too well. How about we do sort of a light gray? Let's say, so this student has an almost white t-shirt. Let's say these two people are out in the sun, so they're receiving red, orange, yellow, green, blue, indigo, violet again. And what happens is the black t-shirt, this absorbs red, orange, yellow, green, blue, indigo, violet, and it reflects no light. The white t-shirt reflects red, orange, yellow, green, blue, indigo, violet, and it absorbs, I don't want to say none, but it absorbs a minimal amount of energy. And so this person would probably feel warmer. And the other person would feel cooler. This person's clothing is absorbing a lot of energy in the sunlight. The person in the white t-shirt is reflecting a lot of energy in the sunlight. Again, this is energy. So if something is absorbing energy, one of the things that can happen is it can warm up. So what we're going to have you do, if you're willing, is put some papers. Yeah, I was delivering to coaches yesterday. So hopefully they make it to you soon. So we took some pieces of construction paper. We cut them out, we laminated them to try to help them maybe be waterproof. We took some thermometer strips and we stuck them on the paper before we laminated it. And what we'd like you to do is set them out in the sun. And again, there are all these colors in the visible part of the spectrum shining on these pieces of paper. They're absorbing some colors, reflecting some colors. So different color papers absorb and reflect different color combinations. And the other thing to think about is this is the low energy end. This is the higher energy end. If you've ever been around a campfire or something and somebody puts a piece of metal in the campfire, as it heats up, you'll see it start to glow red as it starts to warm up. And as it gets hotter and hotter, different colors will start to be emitted. And if something's really hot, it might appear to be white hot, maybe even a little bit on the violet side of white. Again, just reflecting that these different colors correspond to different energies. And so what I would like you to think about So think about if I can set these different colors of construction paper with thermometers attached to them inside of laminating film. Sorry about that. If I set them in the sunlight, will they all warm up to the same temperature? Will they be different temperatures? And if you start thinking there, we'll have some more videos to help you see if you could turn something like that into a hypothesis and actually build an experiment out of it. I believe that's the background that you need, and hope you got something out of this. Thank you.